This video shows how to use utility vector logic and utility reduced logic in Xilinx Vivado tool. For using these features in Vivado, first create a block design, click on OK. It opens a new canvas for adding the designs. Add the IPs, search for utility vector logic is available and reduced logic is also available. First, I will go with the utility vector logic. Double click on it. You can see the utility vector logic with two operands and the resultant. Double click on it to see you can change the bits like 16-bit and or XOR and NOT. Right now, I'll use the 8-bit and click on OK. The utility vector logic will perform the bitwise AND of these two inputs and get the result at this point. To do that, just right click on it, click on create port. You can change the name to A with the 8-bit. Similarly, change this to B, the second operand with 8-bit. The resultant, create a port, and I want to rename this port to Y as output. Click on OK. Once the designing is done, you click on regenerate layout, then validate the design. Validation is successful. Provide the 8-bit data for A and B, then this will perform the bitwise AND and you will get the 8-bit data. Go to the sources. Once the design is completed, change the block design to Verilog. Click on create HDL wrapper. Click OK. The design has changed from block to Verilog. Once this is done, you can click on run simulation, run behavioral simulation. I have two inputs and one output which is of 8-bit. Again, right click on it and provide the value as force constant. Change it to binary and provide a 8-bit data. I'll provide 110 and again 1100. It's of your choice. Click on OK. Similarly, B operand with force constant, binary. I'll provide 8-bit once. all ones. Then rerun the simulation. You can change the radix. Observe that 0 1 AND operation leads to 0. That means it performs bit by bit. First 0 1, the value is 0. Again 0 1, it is 0. For 1 1, it is 1. So it performs the total 8-bit AND operation. Similarly, go to sources, go to the block design again. This time I'll add the utility reduced logic. Let me delete this vector logic. Observe that utility has only one input. It can perform AND or XOR. Click on OK. This time I don't require this second operand, and the output is again a single bit. Input is a 8-bit data. 8-bit data will be performed AND logic, that is bitwise AND for the input, and it predicts the single bit output. Just right click on it, create the port, name it as A. A is a 8-bit data, and the resultant is a 1-bit data. Name it as Y. Regenerate. No errors. Once the designing is completed, just right click on it and create HDL wrapper. Click OK. Once this is done, go to the run behavioral simulation again. This time observe that I'm going to provide a input data of 8-bit binary. So all ones, if I provide, and click on run simulation, which I have provided is FF, all ones. So it performs the bitwise operation of a single input, and the resultant will be a single bit output. Again, if you want, you can change the value. Let me change this value to 1 single 0 overall all ones. Only 1 0 I have added. Click on OK and again perform the simulation. See that the value has changed to 0 for only 1 bit. That means it performs bitwise AND of a single input, and finally it is multiplying by 0. The value is 0. Here it is 1. Here it is 0. In this way, you can use the utility vector logic and utility reduced logic